Okay, so this is just what we're trying to do. And what I would like to show here is, here we have seismic, and this is the wavelet, and this is what we're trying to identify. This is lithofacies from well logs, so this is not from the seismic. This, you can see here, this is the seismic wavelet, this is the petrophysical evaluation. We have here in blue dolomite, in yellow we have sand, we have clay in gray, and lime in green. Here we have the fluids, we have porosity and water saturation. Here I put this crossover, indicating the best part of the reservoir. We have here a wet wet leg here of the reservoir. Things to note in here. Previously, we had the limit of 1/4 of the wavelet, which means this is, if we consider this a wavelet, we were limited to identifying layers as thick as this. Here we can see that we're identifying in 1/4 of a wavelet, we're actually identifying 2 or 3 different layers. Furthermore, with inversion, what we usually obtain is impedances or rock properties. So we're going to obtain here an impedance, a rock property, or we're going to identify top and base of the sand. Whereas in here, we're actually going to try to assign it lithofacies values. In this case, the wet reservoir, the gas reservoir, the pay reservoir, the wet sand, and then in here we have this layer of clay. And this is what we obtain. Here we are obtaining what is the wet sand. I'm going to talk more about the wet sand in just a minute. We have the pay sand, which is in here as well, and then we have in here the shale. So this is lithofacies from well log, and these are the lithofacies that we're going to be obtaining from the seismic. And we're going to be talking on how we're obtaining this.